morning students. I am Dr. C.S.A. Raj from the Department of Physics, Arlananda College, Karmattur. Today we are going to learn a very interesting topic known as an introduction to the properties of matter. Okay? Now, in properties of matter, first we should know about a deforming force. So what is meant by a deforming force? Very simple. A body can be deformed by a suitable application of an external force on it. Such a force is known as a deforming force. For example, you take this ball. So this is an object. This is round in shape. Okay. Now I am going to apply a deforming force. So when I apply a deforming force, what happens? The shape of the ball gets deformed. So by the application of an external force, the shape of the body gets deformed. So such a force is known as a deforming force. Now we will see the proper definition of the deforming force. The force, define deforming force. Okay? The force which change or tries to change the shape or size of your body without moving it as a whole is called a deformation force. So the force which changes or tries to change the shape or size of your body without moving it as a whole is known as a deformation force. Next we are going to learn about elasticity. Okay. Now take this material. This is a scale. It is having a certain length. For example, 30 centimeter. Okay. Now what? See, this is a straight scale. What am I going to do now is I am going to bend it. I am applying a force on both the sides. Now the scale bends and it will be like an arc of a circle. Now if I remove the applied force, again it will come back to its original straight line. So this is the initial shape of the scale. Now when I apply an external force, it bends. Flexibility. Okay. Now when I remove the external force, again it will come back to the original position. Or you take this. So this is a ball. Okay. Now when I apply an external force on it, it gets deformed. When I remove the force, it will come back to its original shape. So this is the original shape of the ball. Okay. So when I apply an external force, it gets deformed. Change in volume of the ball will take place. Volume or size of the ball will take place. And when I remove the external force, again it will come back to its original shape. Okay. So rubber band. Okay. This is having a certain length. Now when I apply a deforming force, it elongates. Okay. It has attained its new length, increase in length. Now when I remove the force, it will again come back to its original length. So this is also an elastic material. So now we are going to learn about the concept known as elasticity. So what is the proper definition of elasticity? The property of a body to regain its original shape or size on the removal of an applied force is called elasticity. So I have applied a force. Okay. When I remove the force, the body will regain its original shape or size. Therefore, this body is an example for elastic body, and the property is known as elasticity. So definition: a body which regains its original shape or size when the deformation force is removed is called an elastic body. Then what is known as a plastic body? This is also a ball. Okay. For this ball, suppose I am going to apply an external force on it. When I apply an external force on this ball gets deformed. Again it will not come back to its original configuration. Therefore, this is an example for a plastic body. Definition of a plastic body: a body which cannot regain its original shape or size on the removal of a deformation force is called a plastic body. Based on this elasticity and plasticity, we are going to learn the concept known as stress, which is more important in this properties of matter. Stress. What is meant by a stress? When I apply an external force on the body, an equal and opposite force will be acting inside the body, which will tend to regain the body to its original shape or size. That opposite force, equal and opposite force, is known as the restoring force. Now, the restoring force acting per unit area inside the body is defined as stress. And stress is equal to F by A, where F is the restoring force and A is the unit area of the body. When an external force is applied to a body, the body gets deformed. Then the force of reaction is set within the body to restore the body to its original condition. See here, when I remove the applied force, the force of reaction acts and the body will regain its original condition, that is straight line. This restoring force is equal and opposite to the applied force. So that is stress. So stress is equal to F by A. There are three types of stress. It is found that the deformation forces may change the length of the material or shape of the material or volume of the material. Accordingly, the stress is divided into three types. Number one, linear or longitudinal stress, shearing or tangential stress, and the third one, volume or bulk stress. Next, we are going to learn about strain. So, what is strain? Strain, it is the measure of the ratio of change in dimension to the original dimension. See, if your body gets permanently deformed due to the application of an external load, then we can say the body has occurred a strain. For example, the change in dimension or shape of your body due to the deforming force applied will result in strain. There are three types of strains, namely linear strain, shearing strain, and bulk strain or volume strain. Based on this definition of stress and strain, we are going to learn elastic limit. So what is meant by elastic limit? The maximum stress up to which a body exhibits the property of elasticity, that is called elastic limit. For example, see here, I am applying an external force. The body gets deformed, that is bending. When I remove the force, it will come back to its original configuration. There is a limit for that. Beyond certain limit, the body will not regain its original shape. It will bend. See, when I bend, what will happen? See here, it will get broken. See here, okay, it gets broken. Because it is beyond the elastic limit. Now, we will learn about Hooke's law, an important definition, Hooke's law. So, Robert Hooke, an English physicist, in the year 1679, gave a relation between stress and strain. This relation is known as Hooke's law. So, definition or statement of Hooke's law. Within the elastic limit, the stress developed inside the body is directly proportional to the strain produced in it. That is Hooke's law. So the condition is within the elastic limit, the stress developed inside a body is directly proportional to the strain produced in it. Stress is proportional to strain, and stress is equal to strain into a constant, or we can say stress by strain is equal to a constant. This constant of proportionality is known as coefficient of elasticity or modulus of elasticity. Thank you.